So, hello everyone. I'm Kunihiro Kato. So, I'd like to talk about the extension sticker. So, in recent year, prototyping techniques allows us to make a 3D object. We can customize the shape of conventional input devices, and also we can recreate the shape of new input devices. However, it is still difficult for the user to add the interactivity to such 3D printed shapes. Many studies to customize the devices have already been proposed. Midas is a method to support the design and fabrication and programming of the touch sensors for interactive objects. By using Midas, the user can prototype interactive devices easily. However, the user has to set the interactivity using a special softwares and connect a wire to the sensors manually. So our goal is a method for the prototyping the interface more easy, and the user can create a variety of interfaces freely. And those interfaces can use without software settings. Then we use the inkjet printer with a conductive ink, so it is very useful to make an interface for the touch panels. For example, we can make the calculate applications and brightness control slider and origami interface for the kids. But today, we propose a totally new method. We call the extension sticker. So now, I'd like to show you the demo movie. On the touch panel of this device, we attach a sticker with multiple conductive lines. And then, when the user touches on the sticker, touch input can be generated. Here, I'd like to talk about the detail of our proposed method. A sticker has multiple conductive lines. They are less than 1 millimeter thickness. When the user touches one side of the lines, they generate a touch input to the other side. Therefore, when the user slides his finger, the lines will be activated in order. Thus, continuous touch input, such as scrolling, is generated. Extension sticker can be easily to create with an inkjet printer. So the user can freely extend touch devices in a variety of ways. We can use flexible materials such as paper. By curving the extension sticker, we can make input portion on the side of the devices. We can use a side or back of smartphones as touch interfaces. And this method is also effective for various devices. For example, smartwatches. This is my smartwatches for this. And I can scroll easily by dragging on the band. We can also zoom the camera and releasing the shutter by scrolling and tapping on the tripod. When we use a selfie stick, usually we use a Bluetooth shutter with a battery inside, but our method does not need any batteries. Our method is also effective not only for the touch panels, but also for touch pads of Note Play series. In this example, the user performs a circular operation. Continuous touch input can be generated. This makes it possible to create a wheel mechanism like a classic iPod. And in this example, touch operation with the palm is transformed to a touch operation with a fingertip. The big display is not touch panel. However, the user can scroll the contents by dragging on the side of it using his hand. In extension sticker, each line have to be thin enough to not generate a touch input by a single line. In addition, the spacing between lines have to tight enough to generate a touch input by multiple lines. I'd like to talking about evaluation. We conducted an experiment to evaluate recognition accuracy of tap and scroll operations. We use a different combination of line, thickness, and spacing. These graphs show the results. The left side shows the result of tap operation task, and the right side shows the result of scroll operation task. In both tasks, recognition accuracy dropped as the spacing grew wider. And if we set the spacing of the lines under the 1 millimeters, the accuracy rate is over 90%. We conducted the same evaluation experiment for the tap operation using other devices. This graph shows the result of the use Microsoft Surface 3 and iPhone 5 and iPad mini. It shows that each device's recognition accuracy dropped as the spacing grew wider and thickness grew thinner. In addition, we tested the scroll operation using more than 10 devices. Every extension sticker allows us to control scrolling operation on all these devices. So this is conclusion. We propose a method that can extend the touch interface by only attaching a sticker. And by using inkjet printer with conductive ink, the user can create easily the prototype of interfaces. We can use it without battery and any transmissions. In addition, we show many applications. And we conducted experiments and confirmed that our method can use on a variety of devices with high accuracy rates. So thank you for listening.
Very interesting talk. Have you looked into alternative mapping of the conducting wires so that, for example, you can map a physical knob? So when you turn the knob, it's actually moving the slide on the screen?
Sorry.
I'm talking about, like, have you looked into remapping the conductive wires on the sticker so that, for example, if you map it onto a physical knob,
yes.
so it's actually like turning, it's sliding through the touch screen?
Yes. Touch screen. Sorry. I see. Yeah, we can. Yes, we can. So I try to. I like to try. This.
Okay. We can talk about it later. Thank you.
Actually, have you thought about how to have a two-dimensional?
Two-dimensional? Yes, I like to. So now, the image.
So this is the end of the session. Thanks, everyone, and don't forget.